for this activity, you are going to need a partner at least. So actually, we're kind of partnered up already. If you guys want to work together, that would be perfect. And then you guys good. All right, so you are going to need a deck of cards. There's a ton of them over here in this box. Just grab one of them. And you only need 5 cards out of the deck. You need 2 aces and 3 kings to play the game. So you're going to grab those. And then you can take turns like dealing to one another or picking cards, however you want to do it. But each of you needs to play the game 10 times. Each person needs to play the game 10 times. How the game works is you pull a card out and you're going to record what it is. So either an ace or a king is going to be the first card. You're going to leave it out. We do not replace. And then you select the second card, either an ace or a king. You win the game if you get 2 aces or 2 kings. So if you get a match, if you get a pair, you win. If you do not get a pair, you lose. So you're going to record ace, kings up here, and then either winner, yes or no. You're going to do it 10 times. For yourself, you're going to record how many times you won the game out of 10. And then as a class, we're going to figure out how many times you won the game and figure out what the actual probability of winning this particular game is. Okay? So grab a deck of cards. Get the 5 cards you need out. Each needs to play 10 times. All right. So we put our numbers on the board. Is that still frozen? Yes, it is. There we go. Okay. And out of, there are 23 of you, so 230 times playing. You guys total 180 times. Okay, so based on our class average, we've got about 0.348 is the probability of one of you winning the game. Okay, so next we want to figure out what the probability overall of winning the game is. So we're going to use a tree diagram to figure out all the different possible ways that this game can go. There's 4 different outcomes. You can get 2 aces, 2 kings, ace, king, or king, ace. Those are the 4 different situations. Okay, so let's say your first card is an ace. What is the probability of the first card being an ace? 2 out of 5, okay? And what is the probability of the first card being a king? 3 out of 5. Okay, so now let's look at the top of the tree here. So we know the first card is an ace. We have left it out of the deck. What is the probability that the second card is an ace? 1 out of 4. What is the probability that the second card is a king? 3 out of 4. Okay. If the first card is a king and we leave that out, what's the probability that the second card is an ace? 2 out of 4. And what's the probability that the second card is a king? Also 2 out of 4. And one thing you can check when you're looking at these probabilities, when you create these, at any given point in time, the probability should add to 1. 2/5 and 3/5 add to 1. The 1/4 and 3/4, that situation adds to 1. 2/4 and 2/4, those add to 1. And then my final set of numbers at the end is also going to add to 1, you're going to see. Okay, so let's find the probability of each situation. Remember when we see and, what are we doing with our probabilities? We are multiplying. Okay, so the probability of an ace and then another ace. So the first ace has a probability of 2/5. The second ace has a probability of 1/4. If I multiply those together, I'm going to get 2/20 or 1/10, or I'm just going to use the decimal, 0.1 is that probability. Okay, the probability of getting an ace and a king. Okay, so an ace, 2/5, a king is 3/4. Multiply them together. That's 6/20 or 3/10 or 0.3. Okay, a king and then an ace. First card being a king, probability is 3/5. Second card being an ace, probability is 2/4. If I multiply them together, again, I get 6/20, which is 0.3. And then last but not least, again, 3/5 and 2/4 gives me 0.3. And again, if you add up all those probabilities, you're going to see the sum there is equal to 1 all the way down. So we've accounted for all the different situations that can happen. Find the theoretical probability of winning the game. So remember, there are 2 ways that we can win this game, 2 situations. Either an ace-ace or a king, king. Okay, so the probability of getting an ace and an ace is the one at the top. That was a 0.1. The probability of getting a king and a king is the one at the bottom. That was a 0.3. If we add them together, the theoretical probability of winning this game is 0.4. So you guys were pretty close. We were like, what, 0.34? Oh, 0.348. Okay. All right, next question. What is the probability that the first card was a king given that the person won the game? Okay, and this is the type of question we're going to practice with for the rest of the period. When we say, given that the person won the game, we are not looking at everything in this chart. We are only concerned about the groups that won, which are the ace-ace group and the king-king group. Everything else is irrelevant because we know the person won the game. Our job is to figure out if the person won the game, what is the probability that they won because they pulled a king first. When we say given that they won the game, that changes our denominator because it's not everybody. It's just the 0.4, the 0.4% of people, or 40% of people that won the game, okay? Our given is going to be our denominator. The numerator is the portion of that we're looking for. In this case, the people that pulled a king first. And you can use the numbers right above it to help you. Out of that 0.4, 0.3 came from king-king, and 0.1 came from ace-ace. So we're looking for what is the probability that they got a king first. That's the 0.3. So it's 0.3 out of 0.4. And that ends up being, if I divide, 3/4 or 0.75 would be that probability. Okay? All right, so flip your paper over. Let's try some more questions like that. We saw this yesterday. If you see this notation, it's going to be on your purple papers too. This is that word given if we see that bar there. Okay, given that something happened, you're going to see that in all of our questions. All right, 2 cards are selected from a standard deck of 52 playing cards. Find the probability that the second card is a queen given that the first card is a king. Okay, so one common mistake here is people will find 2 probabilities and like add them or multiply them together. There's only one probability we're calculating. We already know that the first thing happened, so that's irrelevant as far as like multiplying, adding, calculating with it. Only the second thing is what we're calculating the probability of. We know, we're going to start with our given, that the first card was a king. Okay, so the king is not replaced. The given is going to be what affects our denominator. If the first card was a king and the first card is left out, how many cards are left? 51. Okay, and now I'm calculating the probability of a queen. How many queens are in the deck? 4, and that's our answer. You can turn it into a decimal if you want. That's all we have to do for these. Okay. Table below shows the results of a survey in which 2,276 social media users were asked whether they have been offended by something, posts, comments, or photos they saw on social media. Find the probability that a user is male, given that the user was offended by something on social media. First of all, I want to point out that they have nicely already totaled up things in this table of information for you. If you do not have totals, the first thing you want to do on like Math Excel, quizzes, tests is sum up all the rows and columns because you're going to need those totals for your probabilities. All right, we are finding the probability that the user is male, and I'm again start with the givens, given that the user was offended by something on social media, which means we are only concerned about that part of this table, the people that were offended by something on social media, which is the first column of information, is the only thing that's relevant here. How many people total were offended by something in social media? That's my given. It's my denominator, 1,151. Out of those 1,151, we want to now figure out what's the probability that I select a male. So it's just from that subgroup there are 532 males. And then again, you can divide it to turn it into a decimal or if you want. That's our probability. Okay. Any questions on that? All right. The table below shows the results of a survey in which 250 males and females ages 25 to 64 were asked if they contribute to a retirement savings plan at work. And again, they totaled up for us already. What is the probability that a randomly selected worker contributes to a retirement plan given that they are male? Start there and work backwards. We are only concerned about the males in this table. How many total males are there? That's my denominator. And I'm finding the probability that they do contribute to a retirement plan. So how many out of the males contribute to a retirement plan? 116, and again, you can turn it into a decimal. Okay? The one below there, find the probability that a randomly selected worker is female, given that the worker, start with that, contributes to a retirement plan. How many people total contribute to the retirement plan? 259. And out of those 259, how many are female? 143, and whatever that decimal is our probability. Okay, make sense? All right, so that's the only new part for today. I have for you an exit ticket. I'm going to give you each a copy of it, but if you want, you can work with a partner and turn in one. Just put both of your names on it, or all three of your names on it. Okay, or if you want to work individually, that's okay too. This is going to be pretty similar to the Aces Kings problem. You can kind of use that one as an example with the diagram to help you through it. Put it in the tray when you're done, and then the rest of the period is yours to work on homework today. 3-2 Math Excel is due tomorrow night. Yeah. 1, 2, 3, 4, 5, 6. There you go.